Alrighty, so today we're going to be finally looking at horizontal translations. So we now know how to fully transform the function. So c, and as you can see in the function, it's sine x minus c. C, when we move it to the right, shifts the whole function to the right. As we shift it to the left, it moves us to the left. But notice it's a minus in the rule, which means that it's always the reverse. So that means if you've got, say, minus 3, which would be in this case, then you can see the whole thing's been shifted 3 over to the left by 3 units. And if we do like minus 2, you can see the whole thing's been shifted 2 units to the left. Weird thing is that we're rarely going to see numbers like that because we're going to be dealing with the phase shift that represents a sensible transition in radians. So instead of moving 2 radians isn't really a thing that we deal with that often. So instead we might move it, say, pi on 2. So that shifts the whole function pi on 2 to the right. Alrighty, so we've got a kind of basis. Now let's go through and do it. So the biggest thing is let's just write out our sine and cosine functions with all of the different transformations all at once. We have our two functions, one for sine and one for cosine. And you can see the main thing that I want us to focus in on is the way that b and c interact with x. It's x minus c and then times by b, and that's really important. And just as a reminder, this is how we work out everything. So I'll just put all of the sort of definitions down the side as well. Alrighty. So the amplitude is the absolute value of a, the period is 2 pi divided by the absolute value of b, the median is equal to d, and the range we can think of as being d minus the absolute value of a and d plus the absolute value of a, just meaning d minus the amplitude and d plus the amplitude. And I should make this a y as in. Alrighty, so that is basically a good sort of standing for these sorts of functions. The more interesting part is the new part, which is what a c means. So c is what we call a phase shift. Okay, and a phase shift just means that we're not changing the shape, we're just shifting when does it begin. So we're playing with time in this sense. We're not playing with the actual values, we're playing with time. So we're moving everything left or right. Alrighty, so we've got one function and we want to sketch it. So let's first identify our different values. So a is equal to 1, b is also equal to 1, c is equal to pi on 4. Notice we switched the sign for pi on 4. And d is equal to 0. So this kind of sets out our values, and now we can work out the important features. So we can see that our amplitude is 1, and our period is just going to be 2 pi, because we haven't done any changes there. So our period is just going to be 2 pi. Based on the rule, 2 pi divided by 1 is just 2 pi. The other interesting thing is to think about our max and our min, so thinking about our range. So our max is going to be 0 plus 1, and our min is going to be 0 minus 1. Okay, so this is going to be a fairly sensible sine function. The main change that's going to happen is that it's going to be shifted left or right. So first of all, what I always suggest to do is sketch the whole function without the phase shift. We'll deal with this at the end, okay? So let's go through, set up our axes. It's a sine function, so it's going to start in the middle. Its period is 2 pi, so it's only going to repeat itself after 2 pi. And then in the middle here is going to be 1 pi, pi on 2, and then 3 pi on 2. So there's going to be our main markers. And the standard sine function, being that the maximum is 1 and the minimum is -1, is going to be 0, 1, 0, -1, 0. And this would be our standard function. In fact, this is the graph of y is equal to sine x. Okay, not very exciting. We know this function quite well. So how do we do the phase shift now? Well, what we need to do is move all of these key points, these 1, 2, 3, 4, 5 key points, and move them based on the fact that the phase shift is pi on 4. So how do we do that? Well, that is going to mean that it is going to move pi on 4 units to the right. Alrighty, that's how we can read that. So it's pi on 4 units to the right. So that means this point here is going to move pi on 4 units to the right. So before I start, let's just put in my pi on 4 dividers as well. So there's pi on 4, there's 3 pi on 4, there's 5 pi on 4, and there's 7 pi on 4. Alrighty, so now I've got all my divisions. I'm going to move each point pi on 4 units to the right. So it's just going to move that point there, this point there, this point. Now this point here is actually going to move out of the domain, so it's actually just leaving. Because remember, the domain is from 0 to 2 pi. So this is going to give us a picture of the graph that we actually want. Now, there's 2 points that are really important that we haven't sketched in, and that's going to be our endpoints. Because our endpoints are going to appear at strange intervals, right? We're going to have some kind of crossing over here, and we're going to have a similar crossing over here. It's going to be really important that we know what that value is. So how can we work it out? Well, the easiest way is to just sub in some values. So if I want to know what the value of y is when x is equal to something, well, the easiest thing to do is to actually just sub in that. So let's say x equals 0, well, we're going to get y of sine of 0 minus pi on 4. So what's the sine of negative pi on 4? Okay, well, we can draw a little unit circle. That's that angle down there. The reference angle is just pi on 4, and we're in the cos quadrant. So it's going to be negative sine of pi on 4. And the sine of negative pi on 4 is just going to be negative square root of 2 on 2, or 1 on the square root of 2, whichever you prefer. Okay, so that's one endpoint. So the first endpoint down here is going to be at 0, the square root of negative the square root of 2 on 2, which makes sense visually. Like, you can actually visually see that that makes perfect sense. Let's do the same thing, but for the other endpoint. I've seen a few people get a little bit stressed out by looking at stuff like this. Just remember, we can always write this as 8 pi on 4, just write it as a fraction, and we're just taking away 1 pi on 4. And so this is going to be 7 pi on 4. Alrighty, using our unit circle, we can sketch this in. So 1, 2, 3, 4, 5, 6, 7. So it's going to be down in this quadrant, which is the the all stations 2, so it's also going to be negative. And the reference angle here is going to be pi on 4. So it's going to be negative sine pi on 4. So it's going to have the exact same value as the other one. So it's going to be negative square root of 2 on 2. Which also makes sense because since the period is 2 pi, it means that the values repeat after 2 pi. And since the value over there is going to be negative square root of 2 on 2, then the value over here at 2 pi also has to be negative the square root of 2 on 2. So whenever you're sketching some functions, it's always good to make sure that, if possible, put your endpoints in, because those are going to be key points. Alrighty, so that is how we sketch using phase shifts. See you in the next one. Goodbye.